In this video lesson, we are going to look at nature of roots, and as usual, just to remind you on how to do mathematics. So make sure that you understand each step in the examples. You will not learn how to do maths by reading it or watching someone else explain it to you. Understanding the steps does not mean you can do it on your own yet. Therefore, to get the most out of this lesson, make sure to pause and do the questions before watching the answers. Then, improve your skills only through practice, but more specifically, marking your practice times and learning from your mistakes. Okay, so overview of what we'll be doing. First of all, we're going to look at the discriminant properties, and then we're going to see at how to find the values, and then finally we're going to look at proving values. So to begin, the discriminant is equal to b squared minus 4ac. And before we go on, let's just remind ourselves where this comes from. Now, when we look at the quadratic equation or the quadratic formula, we can see that the discriminant is the value or the expression that lies under the square root. And where we use the quadratic formula is when we have a quadratic equation in the form of ax squared plus bx plus c equals to 0, we can use the quadratic formula to solve for the values of x, or to find the roots of the quadratic equation. And we do this by just simply substituting in a, b, and c, that represents values. We substitute it into our quadratic formula, and this will give us the values of x. Now, in other words, it will give us the roots. So the discriminant can be one of two. It can either be less than 0, or it can be greater than or equal to 0. Now, when we have the discriminant being less than, if this value, after substituting in the a, b, and c values, if it comes out a negative value, less than 0, that means you'll have a negative value in a square root. And we know that a negative value in a square root is non-real. So then your roots will be non-real. Otherwise, if it's just 0 or greater than 0, it obviously will be real. Then we can further divide it into the discriminant being actually either equal to 0 or it can be greater than 0. So when the discriminant is equal to 0, if we look at this, if this is equal to 0, it means that there won't be a plus or minus option here. This will fall away, which means that whereas your roots, it normally, a quadratic equation always has two solutions, both the solutions will be the same answer, because there won't be one with a plus and one with a minus. So if this is 0, it basically means that your roots will be equal and rational. Now, we've just discussed why it would be equal, because this goes to 0, and then you just have minus b over 2a, which is equal to both the roots. But rational, because if this falls away, you are basically left with b over a, and they are integers, so you'll have an integer over an integer, and that would make your roots also rational. And then if the discriminant is bigger than 0, obviously you'll have this square root, and you'll have these one with a plus, one with a minus, so your two roots will be unequal. And then finally, for roots being unequal, we can further divide it into two options. Either the discriminant can be a perfect square, or it cannot be a perfect square. And if it's a perfect square, what's going to happen, like if this is 49, then the square root of 49 is 7. So then you'll again just have an integer over an integer, or in other words, it will then be rational. And if it's not a perfect square root, then you're going to have a irrational root. Yeah, so this is the summary of what happens depending on the value of the discriminant. Now, without solving, determine the nature of roots of x, brackets x minus 2 plus 1 equal to 0. Now, before we can start, we obviously need to put this equation into its standard form, where we have it in the form of ax squared plus bx plus c. Doing that, we multiply out the brackets, so we have x squared minus 2x plus 1 equals to 0. So now we can clearly see A value is 1, B value is -2, C value is 1. So my discriminant, if I now just substitute those values into the discriminant, which is b squared minus 4ac, I can determine what the nature of roots will be. So -2 squared minus 4, a is 1 and c is 1. Right, this is easy to calculate without a calculator because this just becomes 4. The square makes this a positive number, -4, and that gives us 0. Now, first of all, remember how we set it out. So there were 3 distinctions. You first ask yourself, is it real or non-real? That was the first distinction. And if it was less than 0, it would be non-real. Greater than or equal to 0, it is real. So you say, okay, it is real. Then you ask yourself, is it equal to 0 or greater than 0? If it's equal to 0, it would be equal roots and rational. If it's greater than 0, it would be unequal roots. So we have it equal to 0, so meaning it would have equal roots and it would also be rational. And then you're done. Okay, so question 38.1, without solving, determine the nature of roots. All right, already in standard form, so I can just simply start and say discriminant is b squared minus 4ac and substitute my values. So b is -13 squared minus 4, a is 6, and c is 4. Okay, now this one we are going to type into the calculator. Just be careful to make sure that you substitute in the b value, or actually all your values, just to be safe, inside brackets, because if you don't, the negative is going to just give you the wrong answer. And then 6 and then 4. Okay, so this gives us 73. Right. Now, first of all, ask yourself, real or non-real? So less than 0 or greater than or equal to 0. So this is going to be real, right? Next question, is it equal or unequal? So this is, if it was equal to 0, if this was 0, it would be equal. If it's greater than 0, it's unequal, so unequal. And then the final question you ask yourself is it rational or irrational? So this is not a perfect square, therefore this will be irrational. Right, without solving, determine the nature of roots. Now we need to put this into standard form, obviously. So x squared minus 3x plus 11 equal to 0. And then discriminant is equal to b squared minus 4ac. And substitute in -3 squared minus 4. A is 1, C is 11. Okay, then we have 9. So we can put this in. We have 9, minus 3 squared is 9. 9 minus 44. So this is -35. Right, first question, is it real or non-real? So this is less than 0, so that's going to be non-real. And if it's non-real, then it's where it ends. Yeah, if it's non-real, it's non-real. Then for this one, okay, so it looks complicated, but it's just basically to first put it in standard form by first multiplying out your brackets. So x squared minus 13x plus 3x plus 9 equal to 0. Right, and then we have x squared minus 10x plus 9 equal to 0. So the discriminant is equal to b squared minus 4ac. And then it is equal to -10 squared minus 4. A value is 1, c value is 9. Okay, so this is 100 minus 36, so this gives us 64. Okay, first question, real or non-real? So bigger than 0, so that means it's real. Next question, is it even or uneven? Now it's not equal to 0, it's bigger than 0, so that means it is uneven. And the final question, is the roots rational or irrational? Is it a perfect square or not a perfect square? So this 64 is a perfect square, it's 8 squared, so that means it will be rational. And done. Okay, right, so that was basically the properties. And now let's move on to finding values. So these questions look as follow. Given 4x squared plus 2kx minus k equals to 2x, determine the roots of the equation if it is given that they are equal. All right, now there is a certain steps that you can follow for this. So the first thing, obviously, like we always do, put it in standard form. So let's start by just doing that, and then we'll look at the next steps. We have 4x squared plus 2kx minus 2x minus k equal to 0. And we group the like terms because remember, with this quadratic equations, we have x squared terms, x terms, and constant terms. So 4x squared, these two are like terms, so I'm just going to group them together. 2k minus 2x, I'm basically just pulling the x out. So my coefficient of x in terms of k will be 2k minus 2 minus k equals 0. Okay, so now that it's in standard form, you need to look for the keyword. And the keyword says that determine the roots of the equation if it's given that they are equal. So this keyword will tell you what the discriminant needs to be. Now we saw that if the roots are equal, the discriminant must be what? It must be equal to 0. So then I just say, okay, my discriminant is equal to 0, and I know my discriminant is b squared minus 4ac equal to 0, and then I just substitute in my a, b, and c values. So a is 4, b is 2k minus 2, and c is minus k. So this is all in terms of k. So 2k minus 2 squared minus 4, a is 4, and c is minus k equal to 0. Right, simplify. So just going to square this out the fast way. Square the first one, so that's 4k squared. Multiply together, multiply by 2. That's minus 4 times by 2 is minus 8. Okay, square the last one, plus 4. Right, simplifying this, we have a minus and a minus, which becomes plus. 4 times 4 is 16, and that is k equal to 0. And then add your like terms, 4k squared plus 8k plus 4. And yeah, now we can just solve. So this we can simplify by just dividing every term with a 4k squared plus 2k plus 1 equals to 0. Factorize k plus 1 equal to 0. So k plus 1 equals to 0. Therefore k is equal to minus 1. Okay, and that's basically our answer. So just to recap on what we just did, you basically have your expression in terms of another variable, and then you put it in standard form. So that's your first step. Then you look for a keyword. So here it says that the roots must be equal. So you can go back to your notes and see, okay, if the discriminant is or if the roots are equal, what must the discriminant be? So then the discriminant will be equal to 0. Then you just basically substitute in and solve. That's about it. All right, now let's see you try one. Okay, this one is already in standard form, and it says determine the values of p for which the roots are non-real. So my keyword is non-real. So my discriminant, when my roots are non-real, is when the discriminant is negative or less than 0. So b squared minus 4ac is less than 0. Now substitute in, b is negative 4 minus 4, a is 1, and c value is b, less than 0. Okay, and this becomes 16 minus 4p is less than 0. And then we solve for this inequality, so the 16 goes over, minus 4p less than negative 16, divide both sides by negative 4, p is greater than 4, because just a reminder, when you're solving for inequalities and you're dividing both sides with a negative number, your sign changes. All right, and that's your answer. Then find the values of k for which the equation x squared plus 4x plus 9k equals to minus 2kx has unequal roots. Right, first of all, standard form. So x squared, this guy just needs to jump over, plus 4x plus 2kx plus 9k equal to 0. Okay, we have these two terms which are like terms. So x squared plus 4 plus 2k x plus 9k equals to 0. So a is 1, b is 4 plus 2k, c is 9k. And our keyword, unequal roots. When it's unequal roots, it means that your discriminant must be greater than 0. So b squared minus 4ac must be greater than 0. So I substitute in. We have 4 plus 2k squared minus 4, a is 1, and c is 9k, greater than 0. Simplify, 16 times by itself is 8 times by 2 is 16, so plus 16k plus 4k squared, and then minus 36k greater than 0. Add the like terms and just reshuffle it to be in standard form. 4k squared plus 16 minus 36 is minus 20k plus 16 is greater than 0. Divide everything by 4, k squared minus 5k plus 4 greater than 0. All right, in this case now we have a inequality to solve that is a quadratic inequality, and we have done this in the previous lesson if you've watched that. So you can now obviously either use the graphical method or the algebraic method. So I'm just going to use the graphical method. So first of all, we can factorize it so long, but we need to find the roots of k now. So if we factorize this, we get k minus 4, k minus 1 greater than 0. So this is this one is positive. This quadratic is a positive quadratic equation. So we're going to draw it up, smiling. Our roots are k equal to 4 and k equals to 1. Okay, so it's going to be at 1 and at 4. Now this one is greater than 0, meaning it lies above the x-axis. So this is our x-axis, or in this case our k-axis. But so lying above means it's this part and this part, the part that lies at the top. So for the k values or the x values, it's going this way and this way. Okay, so k lies here and here, meaning that k is less than 1 or k is greater than 4. And that's our answer. Calculate the values of k for which that equation will have equal roots. Now this could look daunting, but it's actually, just putting this in standard form, you can treat this as one term by just putting brackets around it and then using cross multiplication. So you can just multiply that up with k, and then it would look something like this, equal to k 2x plus 4, and then multiply out the brackets and put it in standard form. So minus 3 equals to 2kx plus 4k. Everybody to one side. X squared minus 2kx minus 4k minus 3, and that is equal to 0. All right, and then just group the same, the like terms together. We can see here that our a value is 1, our b value is minus 2k, and our constant, or our c value, is all of this, or these two terms, minus 4k, minus 3. Right, the key word is equal roots. So for equal roots, we know our discriminant must be equal to 0, so the discriminant must be equal to 0. Therefore, we have b squared minus 4ac equal to 0, and then we substitute in. So b is minus 2k, so we square that, minus 4, a is 1, and c is minus 4k minus 3 equal to 0. And simplify, this becomes 4k squared. So here, ignore the 1, multiply in the negative 4 into these brackets, and a negative becomes a positive. So this is plus 16k, negative and negative positive, plus 12, just 12, there's no k there, equals to 0. So here we have 4k squared plus 16k plus 12. We can simplify this by dividing everything with a 4. K squared plus 4k plus 3 equals to 0. Factorize k plus 3k plus 1 equal to 0. So k is equal to minus 3, or k is equal to minus 1. Okay, so hopefully that wasn't too hard. The next one, proving values, is slightly harder, but only at the end. Most of the steps look pretty much the same, but the end can be challenging. Yeah. All right. Example 40. Prove that the equation 6x squared plus x and then brackets 2p minus 3 minus b equals to 0 has rational roots for all rational values of b. All right. Now, remember when you have this question in an exam, normally in question 1, one of the last questions, when it says find the values, you do what we previously did. When it says like prove, well, this is what you do. So remember, we're also going to have to start by putting it in standard form, and this is already in standard form. We have our a value as 6, b value of this as this, and our c value is minus b. Then we also have our keyword. So it says this will have rational roots. Okay, so rational roots for all rational values of b. Now, in the previous one, we used the discriminant to set up an equation. In this case, we are going to set it up as a expression. With that, I mean you start with the discriminant is equal to b squared minus 4ac, okay? That's what it's equal to. Then you obviously just substitute in your a, b, and c values, but now it's not an equation, it's an expression. It's like, this is what it's equal to. So there's no solving, this is what it's equal to, and we need to prove that it's going to be rational roots. Now, when the discriminant has rational roots, remember, it can be one of two. Either the discriminant must be equal to 0, or the discriminant must have must be a perfect square. All right, so one of those two things we need to prove. So basically we're going to substitute in our values. So b is 2p minus 3 squared minus 4, and a is 6, and c is negative b. Okay, then you just simplify. So we have 4p squared times by itself times by 2 is negative 12p. Square the last one, plus 9, and then plus 24b. Okay, add like terms. So 4p squared minus 12 plus 24. So this gives us positive 12p plus 9. Okay, now this is where you're going to have to kind of be creative, because we need to show that this is a perfect square, or it's equal to 0. So what we can do now, one of the things we can try is now just to factorize it and see if it maybe shows us something in its factored form. This is a trinomial. So we're going to use the Excel method. 1 times 4, 2 times 2, and 4 times 1. And then 1 times 9, 3 times 3. We need to get plus 12. So 4 and 9 can't give us 12. 2 and 18 can't give us 12. Let's move on to 2 times 3 is 6, and 2 times 3 is 6. So this one, 2 times 3 is 6, and 2 times 3 is 6. Okay, and to get plus 12, I need to say plus, so plus there and plus there. All right, so this is going to be 2p plus 3 and 2p plus 3, which can be rewritten as 2p plus 3 squared, which actually means we've just solved, we've just proven that this expression, our discriminant, can be written as a perfect square, because for any value, any rational value of p, whether it be 2, 3, 4, when you take a number and you square it, it's going to be a perfect square. So therefore we can say that the discriminant, is a perfect square for all values of p, and therefore roots are rational. Yeah, and then we're done. Okay, 40.1. Given 4x squared plus 2kx minus k equals to 2x, prove that this equation has rational roots for all rational values of k. Standard form, we have 4x squared plus 2kx minus 2x, need an x there, minus k is equal to 0. Group the like terms, 4x squared plus 2k minus 2x minus k equal to 0. All right, and then we start. So we have, the question says it has rational roots. So first of all, ask yourself, what do we need to prove if it has rational roots? We need to prove that the discriminant is either equal to 0, or that the discriminant has, or that the discriminant is a perfect square. All right, so one of those two things. So we're going to start. If we have a discriminant and it's equal to b squared minus 4ac, and we substitute in our specific values, a, b, and c values, b is 2k minus 2 squared minus 4, a is 4 and c is negative k. Then we just simplify. So 4k squared, multiply with each other, is 4, multiply with 2 is 8. So plus, actually minus 8k, and square the last one, plus 4, and then plus 16k, and simplify 4k squared. This is then plus 8k plus 4. Right, so just remember that this is an expression. Previously we could simplify by just dividing all the terms by 4, but that was because it was an equation. With an equation, what you do on the one side, you can do on the other side. But an expression is like, this value is equal to this. You can't just take a number and divide it randomly. So this is how it's going to stay. But we can start by trying to factorize this. Once again, we can use the extra large method. Let's do it over here. So factors of 4 is 1 times 4 and 2 and 2. On this side, 1 times 4 and 2 and 2. And then flip the side around, 1 and 4. Okay, we need to get plus 8. And if we remember what happened previously, we saw that it ended up with two of the same factors. So the first thing I'm going to try is to see if it's not 2 times 2 and 2 times 2, because that would also give us identical factors, 2k plus 2. So 2 times 2 is 4, and 2 times 2 is 4. So if I add these, that gives me 8. So it's plus and plus. Right, so then if I factorize this, it's going to be 2k plus 2 and 2k plus 2, which is equal to just simply 2k plus 2 squared. Right, and there we've proved that the discriminant is a perfect square. So we can say, therefore, discriminant is a perfect square, and therefore roots are rational for all rational values of k. Right, done. Now for question 40.2, show that the equation x squared plus k, x plus k squared plus 2 equals 0 has no real roots for any real number of k. Alright, so what we're going to do here, this is already in standard form. We need to see our keyword is no real roots. And what is the discriminant when we have no real roots? Our discriminant must be less than 0. It must be negative. So we start off once again, discriminant is equal to b squared minus 4ac. We substitute in our abc values and we prove that the final answer is always negative. Alright, b squared, b is just k, so k squared minus 4, a is 1, and c is k squared plus 2. Okay, then simplify, so k squared, once again ignore this 1, just multiply in the negative 4, minus 4k squared minus 8, and that's equal to negative 3k squared minus 8. Alright, now we have this discriminant is equal to minus 3k squared minus 8. So how are we going to prove that for values of k, this will be a negative value? Now let's start by its simplest form. Let's say we start with k squared, alright, and then we're going to add the values as we go along. Now for k is k squared. K squared is whatever k is. If it's a negative value, if it's 0, if it's a positive value, it's always going to be equal to, greater than or equal to 0. Alright? Anything you can substitute in it, if you square that value, it's always going to be positive. Alright, and then when you take a positive value and you minus it and you multiply it with a negative value, obviously a positive value multiplied by a negative value is always a negative value. So we can say that this minus 3k squared will always be less than or equal to 0 for all values or for any real number of k. Now when you take a negative number or a 0 value, 0 or and below, and you subtract 8 or subtract anything positive, then if you subtract it, it will obviously go more into the negative. So a negative number subtracted by another number will be still negative. So if it was 0, then it would be negative. So minus 3k squared minus 8 will always be less than 0 for all real numbers. Okay, right, and if we've now shown that the discriminant is always less than 0, we have therefore no real roots. And then we're done. Then for question 40.3, show that the roots of px squared plus px minus b equals to 3x minus x squared are real for all real values of p. Okay, standard form, that's our first step. Px squared plus x squared, and then plus px minus 3x, and then minus b is equal to 0. Group the like terms. So we have b plus 1 x squared plus b minus 3x minus b equal to 0. Okay, now our keyword, real. So meaning if it's real, the discriminant must be greater than or equal to 0. Right, so in our case, discriminant equal to b squared minus 4ac, we substitute in our values. B minus 3 squared minus 4, a is b plus 1, and c is negative b. Alright, simplify. So p squared minus 6b plus 9. Multiply in, we can just think of multiplying in a positive 4 for p, because this times this is just plus 4p. So if we multiply that in, we get plus 4p squared plus 4p. And then adding like terms, we have 5p squared minus 2p plus 9. All right. Let's try and factorize this. This is now where the easy part is done. Now we have to start being creative. So let's start by trying to factorize it. 1 times 5, and then on this side 1 times 3, 1 times 9, 3 times 3. This side I'm just going to say 5 times 1. Okay, 15, 3. This should give us minus 2. Nope. Then we have 5 and 9, not going to give us minus 2. 1 and 45, definitely not. 3 and 15, also not. Okay, so this means then it cannot be factorized. Okay, what's the next thing we're going to try? If we look at our p-values, we should try and see that for this always to be bigger than 0, this value is being subtracted. So we want to try and prove that this value, the first value minus the value that's going to be subtracted, that it's going to give us a positive value. We know that if we just compare these two terms, we know p squared on its own will always be bigger than or equal to p, because if you put in a negative value, it's going to become positive, where this one will stay negative, so this one will be bigger. If you put in both positive values, then this one will be squared, which means it's going to be bigger, and this one is just going to stay the same, like 3, this will be 9, this will be 3, 16, 4. If you put in 0, they're going to be equal. Okay, so for negative values, 0 values, and positive values, this value will always be bigger than that value. Now, if you take a bigger value and you multiply it with even a bigger value, like 5, and you take the smaller value, so you take the bigger value, you multiply it by a bigger number than you multiply the smaller value, it's going to still be bigger. So I can say that 5p squared, or I can safely say, is still going to be bigger than 2p. All right. So now, if I take this and I just manipulate this, and I say, okay, let's take this over to this side, because we can see it's negative there. So we're going to say 5p squared minus 2p will be greater than or equal to 0. All right. So we're moving towards this. Okay. So far we've proven that this is always bigger than or equal to 0. Now, if this value is either a positive value or 0, if you take a positive value or a 0 or equal to 0, and you add anything, it's still going to be positive. It won't be 0 anymore, but it will still be positive. So if we say 5p squared minus 2p plus 9, it will always be a positive value, always greater than 0. All right, now we've done it. We've proven that yeah, that it will be real. We've proven that therefore the discriminant is greater than 0, so therefore the roots will always be real. Roots are real for all real values of B. Done. Okay, so that was it.